In this video, we're going to talk about the binomial theorem. Before we can define what the binomial theorem is or what it does, we have to understand what it deals with. So, like its name suggests, we're going to be talking about binomial expressions. So, binomial means two terms or two things within an expression. So we've seen these things plenty of times before. We're very familiar with this one right here, some a plus b quantity to the power of 2. We use FOIL, we expand that out, we simplify. We've done that for years. But as you can probably guess and you've seen before, we can also take that quantity and bring it to any other power. 0 power, 1, 2, 3, 4, etc. Now, there are patterns within this kind of expansion, that help us out here. So it's not just random, it actually follows a certain pattern. So what you see over here is Pascal's triangle, where there are ones on the outside, and every subsequent term, so like this one and this 2, add up to this third here. And you'll notice as I keep going down, I have this middle point, and then it repeats going the other way. So 1, 3, 3, 1, 1, 4, 6, 4, 1. So it goes up a certain way, it hits a certain point or the middle point, and then goes back down with the same numbers. Now, why does that matter? It actually comes into play in the coefficients. So if you notice 1, 1, 1, 1, 1, 1, 1, 2, 1, 1, 2, 1, and etc., right? So if I go down here, 1, 4, 6, 4, 1, there's no surprise that it's 1, 4, 6, 4, 1. And I can keep going. I can use this triangle here. And I can also use something that we're going to talk about in just a moment called a combination. But that's how we find the coefficients. Also notice, if I start with my a, the power of a, when you have a power of 0 to the whole thing, obviously that's going to cancel pretty much everything out. But if you notice, I start with a1, b1. I end with 1 and start with 1. Now, a plus b to the power of 2, a starts with the power of 2, decreases to 1 to 0, where b starts at 0, increases to 1, and ends at 2. Same thing here. I have the power of 3, 2, 1, and 0 for A, and for B, 0, 1, 2, 3. So the first term and the power starts at the highest and decreases, whereas the second piece here starts at the lowest and increases. So there are all these patterns in binomial expansion, which we can then define in our theorem. Alright, so what you're looking at right now is the binomial theorem. First in compact form, and then in expanded form. So we've seen a lot of these elements before. We've seen this notation, we've seen this sigma notation, we've seen powers and addition and all that good stuff before. The thing you may not have seen before is this thing in parentheses that's n and k. Another way to consider it is something called a combination. And if you've ever studied probability before, there are these two basic principles of permutations and combinations. The very quick rundown of that is when I am choosing something, I'm trying to find the probability of choosing like a red sock out of a drawer of red and blue socks. So the deal with combinations is really that it will tell me the number of possibilities given a certain amount of inputs, but the order doesn't matter. If we're talking about permutations, that's the one where order matters. But really what we're doing is we are defining n choose k, which never really made much sense to me. I didn't like to remember it that way. It's just here, n it represents all the things I have to pick from, and k is the number that I actually choose. So if I have 5 socks total in a drawer and I'm picking 2, how many ways can I pick out 2 socks without order mattering? So that's what that big C and combination stands for. We'll talk about probability soon enough. So that's where those numbers come from. In fact, if you recall from the last slide, the Pascal's triangle, that's where those coefficients come from. So you could actually draw a Pascal's triangle if you really wanted to and use that, or you can use combinations. There is a way to do it in your calculator. I'll show you that in just a little bit. So really, you plug in all the things and it's going to create a kind of pattern that we looked at last slide. So in order to make that make any sense, let's actually take a look at an example. Alright, so I'm going to be asked to expand and simplify the quantity of x plus 2 all to the 5th. Now I could do x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2 and do that all by hand and cry a little on the inside and the outside, or I could use the binomial theorem to help me. So the first thing that I have to do is I have to define my A, so my beginning, and my end here, and also the quantity at which I'm going to go to. I'm always going to start at 0. I'm going to use my x and my 2. My x is going to start at 5, count down to 0. 2 is going to start at 0 and count up to 5. Let's write it out. All right, so when I enter in all this stuff, I have 5, choose 0. And then it would be 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, 5, choose 5. And also you notice that x starts with to the 5th, to the 4th, 3rd, 2nd, 1st, and 0. And 2 is going to start at 0, 1, 2, 3, 4, and 5. So I'm going to simplify that. First thing I want to show you is actually how to input this into your calculator. All right, the way to access this string of menus is to hit the Math button, which is the third one down all the way to the left underneath the alpha, and you'll page over until you see this perb or probability, and then you're going to choose the third one, which is NCR. But before you do that, when you are on your main screen, you want to first enter the number. So it's kind of a pain to remember, but you always enter the first number. So if I'm doing this one right here, I'm going to hit 5, go up to Math, hit probability, choice 3, this will come up, and then I choose whatever number happens after it, 1. So that gives me 5, and I would do that for each successive term or whatever it was that I was looking for in combinations. So let's use that to simplify our expansion here. All right, notice in red my expansion terms that I start with, so 1, 5, 10, 10, 5, 1. That's the same pattern that we saw at the beginning of the video. So when I expand this whole thing out and I simplify, I get x to the 5th plus 10x to the 4th plus 40x cubed plus 80x squared plus 80x plus 32. So notice that the coefficients don't always end up being the same thing that you see in the triangle, only because of these numbers that could end up in the back, or if there's a number in front here that might change your coefficient. But you always start with the ones from the triangle. And that's going to do it for this video. Thanks for watching.